we should suffer for this. Don't even bother to explain them. Just hold my hand while I come to a decision on it. Sooner or later, your legs give way, you hit the ground. Save it for later, don't run away and let me down. Sooner or later, you hit the deck, you get found out. Save it for later, don't run away and let me down. Run away and let me down. Hey, what's up, you guys? Welcome to this week's lesson on chemical bonding concepts. So this is kind of a review, just so you know, and this is our Unit 7 of Willamette Promise, so it's our last unit, right? And it kind of acts as a final for this unit. So a big emphasis on it, not only will it cover solutions, which we talked about last week, but it will also cover chemical bonding concepts and review that stuff, the stuff that was back from Unit 3, right? Like naming compounds and identifying types of bonds and stuff like that. So we're going to review that, plus do a couple of small little like new things that you maybe haven't heard of before, okay? So let's get started. So I'm sure you remember this, a periodic table. You've got one. Might be as colorful as this. We'll see, you know, depends on how good a job you did and if you still have your original one. But just a few reminders, right, you guys? Remember this, metals are over here on the left side. And remember, it's not split like in half. It's split right down here. Okay, it's split at the metalloids at this yellow line here, these yellow stair-step elements. So metals on the left side, right? Metalloids are on that stair-step line there, and then the metals are up here in the right-hand corner on the right side. So just a reminder about that. That's important. Okay. Remember, there's two ways to number the groups. You can just go straight up 1 through 18, or you can go 1A through 8A, and that would be 1A and 2A would be over here on the left-hand side, and then 3, 4, 5, 6, 7, and 8 would be on the right-hand side. And then we have the B groups here, which would be the transition metals. Now, I bring this up because for some reason, chemistry people like to number them this way, and it gets referred to on the exam that you're going to take. So one of the things that you need to know is this, is if you look at groups 5, 6, and 7 here, well, what are their charges? If I look at group 5 with nitrogen and phosphorus, they're -3s. And oxygen, sulfur, selenium are -2s. And then fluorine, chlorine, bromine, and iodine are all -1s. So how do we find their charge? Well, one way to remind ourselves is if we subtract 8 from their group number, we get their charge, right? 7 minus 8 gives us -1 for group 7. 6 minus 8 gives us -2 for group 6. And 5 minus 8 gives us -3 for group 5. So that's one way of finding out their charges, all right? Again, I'm referring you to that because that's going to come up on the exam. All right, so a reminder here about types of bonding. Okay, you guys, we have ionic compounds. Okay, remember, ionic compounds have a metal and a non-metal. That's how we tell the difference. Okay, and then here's the deal, right? A metal loses electrons. Sorry, trying to grab my pen here. There we go. Metal loses electrons and it gets a positive charge, right? So it loses negative charges, that makes it positive. And then we have a non-metal. They gain electrons. Non-metals gain electrons and they get a negative charge. Okay. So if you look at this, here is an example of an ionic bond occurring. Sodium gives its electron to chlorine. Okay, the chlorine takes it. Chlorine's a non-metal. Sodium is a metal. Sodium becomes a positive charge. Chlorine becomes a negative. And what holds them together is those opposite charges, right? All right, next thing, we've got covalent compounds. Those are different, right? Here we have 2 nonmetals. Okay, so two things from the right side of the periodic table generally. And then the charges don't matter and electrons are shared. So yeah, you got to keep that in mind, right? Now here's oxygen and hydrogen, okay, as an example of a covalent compound. So this is hydrogen. It's a nonmetal. So even though it is on the left-hand side, Remember, it's a nonmetal, right? And so here are our shared electrons right here and right here. Okay, one electron in this case is from the oxygen, the red one electron, the blue X is from the hydrogen. Okay, sweet. So let's talk about ionic compounds real quick. Okay, remember you got no prefixes on these guys, right? Charges have to balance. We use these Roman numeral things, okay, to determine the charge when you have multiple charges for the same atom. And don't forget, when you have polyatomics, you use parentheses only when you have multiple polyatomic ions that are needed. So here's some examples, all right? We have sodium oxide, okay? So sodium oxide, sodium is a 1+, oxygen's a 2-, right? So that's why we need 2 sodiums to equal out the charges of the 1 oxygen. Here's an example of a multiple polyatomic, right? We need 2 of these PO4s, which are called phosphate, because they are a 3-, right? And the iron, in this case, is iron 2. There's also iron 3, right, you guys? But we know it's iron 2 because if I add up the charges, this has to be a 2+, so that we have 6 minuses and 3 times 2, 6 pluses. All right, last one here, and I'm going to emphasize this because it comes up. Ammonium, you guys, is a polyatomic ion. It is a positive charged one. Make sure you can find it on your periodic table of ions. So if we go ammonium carbonate, I need multiple ammoniums, so I put parentheses around it, 2, and then carbon 8, right? So that means it's more than just carbon. It goes on the end here. I do not put parentheses around that because I only need one of them. Moving right along here, you guys. Okay, good with that? All right, let's talk covalent compounds. Okay, remember, 2 covalent compounds are 2 nonmetals together, right? So 2 things from the upper right of the periodic table, unless it's hydrogen, of course. Okay, and here we use prefixes. If you're like, wait a minute, Flugum, I don't remember those. Here's a chart. You can write them down, man. There's 1 through 10. That's all that you'll need. Okay, so there's that. And remember this: charges do not matter. Sometimes people get hung up on like, well, the 2- and the 3-, and dude, it's nitrogen and oxygen. The charges don't matter. They're nonmetals. This is covalent. Okay, remember they're sharing, right? They're sharing electrons. So here's a couple examples. We got phosphorus trifluoride, right? Phosphorus, when there's only one of the first element, we don't put a prefix on it, right? And then the second one, dichlorine heptoxide. If there's more than one of the first element, we put a prefix on it, right? You can see the formulas there. All right. Let's talk real quick here about covalent bonds, you guys, and when we have multiple bonds. So a single bond, you guys, that is like this, okay, with hydrogen and fluorine. That has this bond right here, this line, represents 2 electrons. 2 electrons, okay? Now if we have a double bond, and you've seen these before, right? If we have a double bond, now we have 2 lines here, okay? This double bond between the carbon and the oxygen, that represents 4 electrons, right? Now we can even get crazy. We can get a triple bond. You can probably see the pattern here. Here's a triple bond, you guys, between the carbon and the nitrogen. Okay, that involves 6 electrons. So I just want to remind you of that, you guys. It's been a while since we've drawn Lewis structures and talked about bonds. So that's going to come up. All right, one last thing, and this may be new, you guys. This is called a coordinate covalent bond. And it's kind of a weird thing, but it's also something that happens in chemistry. And there's a few cases where you just need to understand what's happening a little bit. So a covalent bond is where both shared electrons come from the same atom. So here's what I mean, you guys. When we have ammonia, which is NH3, and it combines with an acid, okay? So here it is. Here's ammonia and its Lewis structure, right? Here's an acid. Remember, acids contain H+. And an H+, you guys, is just a proton. Okay, that's all it is. It doesn't have any electrons around it. It's really just about the simplest thing you can have. Now, it happens when you combine these two together is you get what's called ammonium here. And what's really happening is this, is as this H bonds on, since these are all nonmetals, we're sharing electrons, right? and we get what's called a coordinate covalent bond, where both electrons, right, these electrons over here, become shared between the nitrogen and this hydrogen nucleus or hydrogen ion that comes in, right? So that's called a coordinate covalent bond. And I hope you're writing this down in your notes because there's going to be a question about it. Okay? All right, just to wrap things up, you guys, here's what's coming up, because reality is this, dude, we only have like 4.5 weeks of school left. Okay? So on Wednesday, I'm going to have another quick PowerPoint just to kind of make sure I cover all the information, all the bases that you'll be tested on. Okay? And you'll get the review that day as well. Okay? Then next week, that's the 18th through the 22nd, that's the Unit 7 test. We'll schedule that. It'll be on Socrative, just like it was last time. And testing format will be really similar. Okay? And then the week of the 24th through the 28th, which is the week of Memorial Day and stuff, we'll have 2 assignments. You guys will have the virtual lab, or for those of you that the virtual lab didn't work for, we'll have an alternate assignment. Okay, that'll kind of cover the same stuff. And then you will also get the environmental chemistry assignment, which for those of you that are earning the Willamette Promise credit, that is the last box you need to check, is doing that project or that assignment. Okay, and that'll pretty much take us till the end of the year. You guys, we might do a lesson or two just to kind of wrap things up. But yeah. Just so you know, sorry, as I say that, this environmental chemistry assignment is kind of a long, involved assignment. It may take you several hours to do, so I'll give you, that'll cover more than one lesson for our class. All right, well, thanks for tuning in, you guys. Have a great day, and I will see you sometime soon. Bye-bye.